Ever wondered what type of engine commercial aircraft uses? There are two main types, turbofan and turboprop engines. Turbofan engine works utilizing the Brayton cycle. The big fan in the front of the engine sucks air into the engine core. There's a big portion of air bypass outside the core, but we will get to that later. Airflow is now forced into the engine compressor. Each compressor stage compresses the air and increases its pressure more and more. This high pressure air is then mixed with jet fuel in the combustion chamber and ignited, causing it to heat and expand rapidly, shooting out the back of the engine, producing some thrust. This drives the engine turbines. The engine turbines acts as a windmill and converts that energy to power the fan via a shaft. Remember the bypassed air? The fan pushes a large volume and mass of bypassed air which generates a large portion of the total thrust of the engine. Turbofans are most efficient at high speeds and altitudes, making it well suited for large airliners and long-haul flights. Example of turbofan aircrafts are Airbus and Boeing aircrafts. Turboprop engines are similar to turbofan engines, but instead of producing thrust from exhaust gases and the fan, the energy is sent via a shaft to a reducing gearbox which connects to a propeller. Since turboprop propellers are rotating at a relatively slower speed, turboprop aircrafts are more efficient at lower speeds, around 250 to 350 knots, and lower altitudes, around 18 to 30,000 feet. This makes turboprop aircraft well suited for regional and shorter route destinations. Example of turboprop aircraft are ATR-72 and the Dash 8 Q400s. I hope you learned something new. Ever wondered how do aircraft push back for taxi? Before an aircraft can taxi to the runway for takeoff, they have to be pushed back from the gate to the taxiway. Pushback tugs are special low-profile vehicles that connect to the nose wheel of the aircraft during a pushback procedure. Once the aerobridge is disconnected and pushback clearance is obtained from the air traffic control, pilots will then communicate with the ramp agents to initiate the pushback procedure. Pilots will release the parking brake and turn on the anti-collision beacon. During the pushback process, pilots are in two-way communication with the ramp agents. In some airports where starting the engines during pushback are allowed, pilots will be in contact with the ground crews to facilitate a safe engine start. Since most modern airliners have reverse thrust capability, why is reverse thrust not used during the pushback? The reason is the resulting jet blast would cause an increase in noise, potential damage to the terminal building and equipment, or even cause injuries to the ground crews. Foreign object debris (FOD) that are sucked into the jet engine may also cause unwanted damages. There was a time in the past where reverse thrust is used for pushback, also known as a power back, but this is not used now. I hope you learned something new. Ever wondered what is an aircraft stall? To stay airborne in the air, aircrafts need to generate lift. Wings generate lift by accelerating air above the wing faster than the air below the wing. This creates a low pressure region above the wing and a high pressure region below the wing. This pressure differential causes a net force upwards called lift. A smooth or laminar airflow around the wings is required for stable lift generation. As the angle of attack of the aircraft is increased, the smooth laminar flow starts to experience flow reversal. This causes the airflow to turn turbulent and separate from the aerofoil. As the angle of attack is increased further, the point of separation moves forward. There is a point where the flow separation is so severe that lift generator is no longer sufficient for level flight. This is known as the critical angle of attack, usually around 16 degrees. The aircraft stalls and essentially falls out of the sky. To recover from a stall, pilots have to pitch the nose down. The goal is to decrease the angle of attack of the wing below the critical angle of attack, allowing the wings to regain sufficient lift generation once again. Power or thrust may be added as required. I hope you learned something new.
How does an aircraft maintain cabin pressure?
Ever wondered how does an aircraft maintain cabin pressure? Commercial aircraft cruise at high altitudes where the atmospheric pressure is too low for humans to breathe normally. To maintain a pressurized cabin, aircrafts are equipped with pressurization air conditioning kits, PACs. Initially, hot and high pressure air is taken from the compressor section of the engines, also known as bleed air. The bleed air is directed into a heat exchanger. This cools down the hot air into a suitable temperature and pressure for cabin usage. The air is then directed through HEPA filters that blocks 99.97% of airborne particles. This conditioned air is then distributed into the cabin. Aircraft cabins are normally pressurized to an altitude of 6,000 to 8,000 feet, which humans can comfortably tolerate. To maintain constant and correct level of cabin pressure, outflow valves allow cabin air to be vented out of the aircraft. The pressurization system controls the outflow valve, which regulates the cabin air pressure by balancing the air venting out of the aircraft and the bleed air coming in. A pressurized cabin is also the reason aircraft doors can't be opened in flight. Aircraft doors are larger on the inside than on the outside. The high pressure cabin pushes against the lower atmospheric pressure outside, creating an airtight seal. I hope you learned something new.